Section 5.5 is our next stop on our journey of Chapter 5, and Section 5.5 for us is about compound interest. Albert Einstein, one of the great physicists in the world, one of the smartest people who's ever lived in it, once said that compound interest is the eighth wonder of the world. He who understands it earns it, he who doesn't pays it. And then a little more modern for some of you, Warren Buffett, the Oracle of Omaha, he who owns Berkshire Hathaway, or a giant stake in Berkshire Hathaway, said, "My wealth has come from a combination of living in America, some lucky genes, and compound interest." One of my favorite shows for a long time was a show called Futurama. And in the Futurama, they talk also about the power of compound interest. So let's take a moment and watch this clip.
Hey, that's my old bank. Maybe my account's still open.
We don't seem to have your retina scan, your fingerprint, or your colonic map on file.
Yeah, well, I did open the account over 1,000 years ago. What about my ATM card?
Do you still remember your PIN number?
Sure. It's the price of a cheese pizza and a large soda back where I used to work. Panucci's Pizza.
Okay, you had a balance of 93 cents.
All right.
And at an average of 2.25% interest over a period of 1,000 years, that comes to $4.3 billion.
So Fry started with 93 cents and ended up with $4.3 billion. Is that correct? Is this a TV show figment? Well, I think you're going to find that it is correct, and that the writers on Futurama counted among them scientists and engineers and even mathematicians. So they did try to make it as accurate as possible. But we'll prove it once we finish example 2, just to make sure that they are indeed correct. All right, compound interest comes down to this equation. It's similar to the equation you're going to find in your book on page 376, except I like this one better. So let's talk about the elements of this. First, A equals P times 1 plus R over N to the power of Tn. All right, so A is our future value. What's it going to be at the end? Also, it counts the principal plus the interest. P is the principal. It's the start. What are you starting with before you figure out your interest? 1, of course, is 1. R is the interest rate as a decimal. T is the time in years. N is the number of times it's going to compound in 1 year. So if it were compounding monthly, N would be 12. If it were compounding quarterly, N would be 4. If it were compounding daily, it would be 365. So N is the number of compounds in 1 year. Before we start any problem of this sort, we want to break down what are the elements of it. Are we looking for A? Are we looking for P? Do we know the R? Etc., etc. All right, let's make this smaller so we keep track of what's going on here. And let's go ahead and try to attack example 2 on page 377. Example 2 says, find the future value. So they're asking for the A of $10,000, that sounds like a P, placed into account, earning 8%, that sounds like the R, interest per year for 10 years, that sounds like the time, if the interest is compounded, and this is the N values. A is annually, B is daily, and C is how much more is earned by compounding daily. All right, so we're doing an annually and a daily, and then we're comparing the two results here in example 2. All right, let's put down what we know. In either case, we do not know what the A is. So A is the whole point of this operation. The P is the same P. It's $10,000. The R was 8% interest. We want that as a decimal. So 0.08 for us. We don't want to write down 8%. Doesn't work real well. Time is 10 years. So we have that. Great. If time is somehow less than a year, we want to account for that too. Let's say it was for 4 months and for time rather than 10 years. Then our time would be 4 divided by 12 because our time is always based on years. All right, part A essentially tells us that the n is 1. And in part B, it tells us that the n is 365. So this is the number of compounds we're going to deal with. Let's go deal with A first. So A is equal to P, 10,000, times 1 plus the R, 0.08, divided by N, it's 1 time. Time is 10 years, and times the number of compounds, again 1. All right, so this is our setup. Our calculator is going to do all the brunt work for us in this problem to give us the final answer here. We know it's going to be dollars, so we can set that up ahead of time. But now it's time to bring up our calculator and have it do it. And I will show you specifically the order in which you want to work this with your calculator, no matter which calculator that happens to be. We're going to start here, 0.08 divided by 1. Now, I know what some of you are thinking, isn't that just 0.08? Yes, but it never hurts to get in good habits. Obviously, it's 0.08. Then we're going to say plus 1, plus 1. Enter. And then we're going to say to the power of 10, because 10 times 1 is 10. So we're going to raise it to the power of 10. And then once we have that, we're going to say multiply by 10,000. So times 10 with 3 zeros. And we enter to get our final information, $21,589.25. Let's transfer that to our screen here. Now that is the full amount in the account after 10 years. How much in interest did we earn on this? Well, we earned $11,589.25. How do I know that? Because I put $10,000 in it. Everything after that 10 grand is interest. So while the account totals $21,589.25, the first 10 grand of that is what I put into it. So everything thereafter is interest. All right, so that's not a bad amount after 10 years. You know, it's more than doubled. That's pretty good. All right, part B, the only difference to part B than part A is our n value is now 365. So A, once again, is equal to 10,000, 1 plus 0.08 still, but now divided by 365, and to the power of 10 times 365. Once again, it's going to be a dollar amount, so we can go ahead and put our dollar sign here. All right, let's bring up our calculator and see if we can calculate this. Once again, we're going to start here, 0.08 divided by 365. 0.08 divided by 365. Enter. Plus 1. Enter. Raise it to the power of. Now, in this calculator, when I raise power, everything after that button is in the power. So I can say 10 times 365 all at once. But now I'm going to say enter. I have that. And finally, times $10,000. 1, 2, 3 zeros. In this case, $22,253.46. Let's transfer that to our screen. $22,253.46. We're going to round to the nearest second decimal on these problems because it's money. Normally we round to the third decimal, but again, it's money. We're going to round to the second decimal. So over a period of 10 years, this account that compounded daily earned not quite $1,000 more, but again, over 10 years. So it does earn more. The more compounds that you have, the more money you're going to earn. In the end, the amount is really a product of two things: the interest rate that you're getting and the amount of time and compounds that you're doing. More time with more compounds, more money. Higher interest, more money. All right, let's go back to the Futurama problem. In the Futurama problem, we were told that Mr. Fry had a starting balance of 93 cents. So 0.93 for us. We were also told that he earned 2.25% interest, which for us is 0.0225. Since they didn't tell us how many compounds, and this is the future, we're just going to say it's 1 compound a year just because we'll make it easy on ourselves. Especially because we know that he was there for 1,000 years. So if you don't know the show, he was frozen in the year 2000 accidentally and woke up in the year 3000. That's kind of the gist of the show. But let's go ahead and calculate this out and see if the answer is $4.3 billion, as the clip told us it was. Let's bring our calculator back on board here, clear the results here. All right, so again, we're going to start here, 0.0225. We're going to divide it by 1. We're going to say plus 1. We're going to raise it to the power of 1,000. And finally, we're going to multiply it times 93 cents. And the answer is 4,283,508,450. So yes, the TV show did not lie to us for the amount of money that he had. They said roughly $4.3 billion, and that's what it was. 4,283,508,450. So quite a large amount, especially considering you started with 93 cents. Amazing what the power of compound interest can do.